Assalamu alaikum, everyone, and we'll be starting today's class. So, what is the name of the chapter number 4? Motion in two dimensions. Motion in two dimensions, or you can simply say projectile motion. Let's begin. So, you can see a boy is throwing a ball, right? And the ball is not only traveling vertically like this, but it's also traveling horizontally. Means the ball is covering horizontal distance and the vertical distance at the same time. So here we can see that it's a two-dimensional motion, right? So in previous classes, we already studied what? We already studied motion in a straight line, okay? And vertical motion, like you drop a stone, or right? But today in this chapter, we'll be dealing with a motion in which is a combination of these two motions, right? And this type of motion is directly related with many of our daily life processes. Like you can see, the most common game, Angry Bird, is directly or indirectly depends on this information, or throwing a shot put, okay, or for a long jumper or a high jumper, or for an archery, or for a footballer, or for a cricketer, right? Everyone needs some knowledge to flourish, right? And that knowledge is being provided by only from projectile motion. So what is projectile motion? In this type of motion, we'll see what? Not only horizontal motion that you can see in the green one, and the red one, vertical motion, but it's a combination of these two types of motion. Means the body will cover not only horizontal distance, but also the vertical distance, right? This you can see over here. The ball is showing a change in altitude, the change in height, vertical motion is there, and the body is also traveling the horizontal distance. So it's this type of motion, which is the combination of horizontal and vertical motion, this is called projectile motion. Okay, so how can we define this? We can define this, the horizontal motion of a body under the influence of gravity is called projectile motion. Okay, this is simply horizontal motion. This is simply vertical motion. If you throw something, like this, then this is projectile motion. One more definition you can see on the screen. Projectile motion is a form of motion which is experienced by a body or an object or a particle that is projected, that is thrown near the earth's surface. Suppose this is the earth and we are throwing something, like if I throw a ball, right? If I throw a javelin, if I throw a stone, then this phenomenon is there and moves along a curved path under the action of gravity. This is called projectile motion, right? Another way to see its definition, you can see on the screen. When a body is thrown under the force of gravity, suppose someone is standing on a tower, and he throws something with force, then that body will also show projectile motion. So there are two pictures, as you will see on the next screen. One, a curved form, semi-curved form, and the other one, a body is a tower is there, and you push something, as you can see over here. It's a 2D motion, right? Like, see this, a ball is being pushed forcefully. This ball is also showing a projectile motion. And the other one, which is not being forced, this is simply going down. This simply the going down. This one is the projectile one. The other one is going simply going down. This is showing vertical motion. Is it clear? So you can see its animated form. Okay, it's being pushed and it's showing the motion, vertical motion on with the red ball, and the horizontal motion with under the influence of gravity. This is being pushed forcefully and is showing projectile motion. See another example. I hope you understood the basic concept of projectile motion. So projectile motion is very, very important in our daily life, considering the games, and throwing the bullets or firing the bullets, right? Or firing the shells with the help of a cannon, firing a rocket. Everything depends directly or indirectly on projectile motion, right? So, what is next? What are the important points? Focus on the first diagram, right? It's showing that when a body is thrown with upward, like if I throw a piece of stone like this, then there will be some velocity of that stone, of that body, like this, right? As you can see on the screen, the right side, the velocity vector is there. You know that velocity is a vector quantity. Velocity is a vector quantity, right? Since this body will move in two different directions, that is why the velocity vector, recall your previous memory, the velocity vector can be resolved into its components. So here the velocity vector would be resolved into two components, one along the x-axis, horizontal component, and the other one is the vertical component along y-axis. Okay, so what is it in here? You can see on the board, on the screen. When the body is projected at certain angle with certain velocity v, then the horizontal component vx and then the velocity vector is being resolved into two components. What are the two components? The horizontal component vx, and we know that what is the value of x component? The value of x component is vx is equal to v cos theta. And another component is vy. Vy is equal to v sine theta. So these two components will take the body in their directions. The horizontal component would be responsible to move the body horizontally, and the vertical component will change its altitude, would be responsible to take the body to a different height, right? So what is the main point over here? That when a body is projected at certain angle, projected means thrown forcefully, right? At certain angle with velocity v, then the velocity vector can be divided into two components. Vx is equal to v cos theta, vy is equal to v sine theta. All right. So you can see on the screen velocity vectors vx is equal to v cos theta and v is equal to v sine theta. Okay, shell is fired from the cannon, right? Okay, and the velocity vector is divided into two categories, into two components, Vx and Vy. Now, what is the point here? When something is being thrown upward, Earth will start attracting it towards itself again. Come back. Like you throw a ball, then the ball will come down, right? Clear? It means there is a force, there is a opposite force rather for the vertical motion. But for the horizontal motion, there isn't any opposing force. Okay, is it clear? Right? Vx and Vy, two components of the vector. What are we doing? Focusing over here that one of the component will face no opposing force, so there will be no change in its value. And which is that component? The component along the x-axis, the horizontal component. Vx is equal to v cos theta will not be changing. It will remain as it is because there isn't any force to oppose it. Whereas the vertical part, whereas the vertical component of the velocity is being attracted, is being disturbed by the earth force, and its value will change. First, it decrease, as you can see, at point number 1, the velocity is being resolved, is being divided into x and y component. As the shell is going up at point number 2, Earth is attracting it. Its vertical velocity decreased, whereas the horizontal velocity remains same. At point number 3, decreased to 0. And when the vertical velocity becomes 0, the shell will start its downward motion. Okay. Then at point number 4, due to the attraction of the Earth, velocity is now increasing. Which velocity? Vertical velocity is increasing. Horizontal velocity remains constant, no change in it, as it was there in the first at the first stage. Same is here in the fourth stage. Fifth, vertical component again increased a little bit. X component remains same, increased, same. So at point number 7 or point number 8, the bottom line is the horizontal component of the velocity does not change. The vertical component, the y component of the velocity will change accordingly. First it decrease, then it increase. Clear? So what have we done? This is the main point. The velocity first decreases. Which velocity? Vertical velocity. First decreases, then it increases. All right? So same is shown over here and written. The horizontal component remains constant throughout the motion of the projectile, where the vertical component first decreases due to the upward motion, right? And then it increases during the downward motion. Clear? So, suppose a shell is being fired or a rocket is being fired. Might be a short range missile. Short range means a few thousand kilometers, 1,000, right? Or a ballistic missile which travels from one continent to another continent, right? It is fired. And we want to know that what is the exact location after firing the particular missile after for 5 seconds. We just want to know theoretically or practically, or we want to know that how far it would be after 10 seconds. So what do we want? What do we want to know? The distance traveled by the projectile after certain time. This is called horizontal distance, right? So in the diagram, let's suppose something is a stone is fired, a stone is thrown rather, and after time t, it reaches at point P, and we want to know the distance, the horizontal distance traveled by this object, okay, which is s. What is the value of s? We don't know. X, we want to know. It's a horizontal distance. That is why I have chosen over here x. Okay. So from the basic formula of physics, if we want to know distance, we multiply velocity by time. S is equal to v into t. Right? The same formula we'll use over here. So S is equal to v into t. What is v naught over here? V with little bit zero. This is called v naught. V naught means usually we call it initial velocity. So initial velocity in physics is usually represented by v naught. So this body is fired with an initial velocity v naught. S is equal to v naught into t. But since we are interested to know the horizontal distance, that is why we'll consider the horizontal component of the velocity. You know that velocity is being divided into two parts, horizontal component and the vertical component. Since we want to know the horizontal distance, that is why we will consider only the horizontal part of the velocity. So we should replace it by x is equal to v naught x into t. What is x? X is the horizontal distance, and which velocity? V naught x. V naught, what is V naught x? V naught x is the part of the velocity along x-axis, right? And we all of us know that what is the value of V naught x? V naught cos theta. Okay, x is equal to V naught cos theta into t. So this is the formula to find out the horizontal distance when a projectile is thrown with certain velocity. Clear? Right? One thing is ended. Another little bit. Suppose, just recall your previous knowledge. Suppose if you have two vectors, one is fx, one is fx, the other is fy, then this is called the resultant vector, right? Fy, fx, this is called the resultant vector. How can you find resultant vector? By using Pythagoras theorem. Recall f is equal to, or f is equal to radical fx square plus fy square, or you can say that v is equal to radical vx square plus y square using the Pythagoras theorem. So same we can use over here. Suppose we have two velocities. This is the reverse case. Suppose you have two velocities, vx and vy, and you want to know its actual velocity. So what will we do? You will use this formula. If we have vx and vy, then the resultant velocity is given by using this formula. So if it is asked to write a note on projectile motion, then here you will end. I repeat, if it is asked to write a note on projectile motion, then this is the point which is the topic should be ended. So in this note, what will you write? What is the definition of projectile motion, right? Then you will draw the diagram. Then you will write, consider a body which is thrown at certain angle theta with the x-axis into the air, into the atmosphere. Then what will you write? Resolving v into its rectangular components. What are the rectangular components? This and that, right? Then you will mention the vertical component will be changing continuously. You will tell the reason, and you will also tell the horizontal component will remain constant, right? Then you will also show that how can you find horizontal distance after certain time. So this all you will include in the topic. Write a note on projectile motion. Okay. Okay. Now 4 topics are associated with this projectile motion. One is you have already done. What are the four parts? We have to find expressions. We have to find derivations. We have to find formulas. Suppose someone want to find that what is the maximum height, what is the maximum height, right? Then at that time, the maximum height is you will be using some formula. Similarly, the total time of flight means how much time will it take to go from one point to another point. And the third is range. Range means the distance traveled horizontally by a body, and trajectory. In short, you will understand these. In short, we will be finding formulas, we will be finding expressions for these four different topics. Okay, so let's start with the maximum height. So if question is written there, derive an expression for the maximum height of a projectile, then we will do this. Okay, again we start with the diagram. Then we write consider a body which is thrown into the air with velocity with certain velocity v naught at an angle theta with the x-axis, right? Then we say that think here we are going to make an expression for the maximum height reached by the projectile. So we will consider which velocity part, vertical velocity part. And which is the vertical velocity part? V naught sine theta. Vy, Vy is equal to V naught sine theta. So for this derivation for the maximum height, what will we do? What will we do? We will consider vertical component of the velocity. And most important part, for this derivation, you will need 2as is equal to vf square minus vi square formula. This you should remember. Maximum height, oh my god, 2as is equal to vf square minus vi square. Right? So let's start. So what is maximum height? What is this? The maximum height, the maximum vertical distance traveled by the projectile is called maximum height. So for example, someone throws a ball, then what is the height it has reached? Maximum height, that is the called maximum height of the projectile. So what will we do? Resolving V naught into rectangular components, as I told you. As you can see over here, rectangular components, one is V naught X, the other is V naught Y. Okay. And their values are there. V naught X is equal to V naught cos theta, V naught Y is equal to V naught sin theta. For this motion, initial velocity is V naught sin theta. Okay, we'll only consider the vertical portion. And since it goes up at certain point, the body will stop and will start its downward motion. Then at that point, its final velocity would be 0. That's why I have written here Vf is equal to 0. So what is going to be noted over here? That the initial velocity is V naught sin theta and the final velocity is 0. Okay. And since the body is going up, a is equal to minus g. And we have to find the maximum height. Okay. Clear? We will be using this motions equation. 2s is equal to vf square minus vi square. What we did here, we have resolved velocity into its two components. Since we'll be discussing, we'll be deriving equations for the vertical motion. That is why what will which component will we use? V naught sine theta. The other data is Vf is 0, A is equal to minus G, and S is the horizontal, is the vertical height. Okay, let's see the second and the last slide. From the equation of motion, we have now, considering this equation, the data is, you can see on the right side. Here's the data. So what will we do? We will substitute the values. The value of A is minus G. The value of S is H. H means the vertical height. Initial final velocity is 0. Initial velocity is V naught sine theta. Okay. Solving, minus 2gh is equal to, what is the square of 0, 0? And V naught sine theta, if we square it, we'll get V naught square sine square theta. Do not write, never write sine theta square. You have done in your math class, right? Further simplifying it, minus minus cancel, and since we are willing to find out the value of h, that is why 2 and g would be transferred on the right side. And this is the final equation for the height, maximum height of a projectile reached. So if the question is there, derive an equation for the maximum height of a projectile, then the question would be ended over here. Okay. What is your homework assignment? It was already given yesterday, but repeating, and you will submit it in the Google Classroom. Okay, you are going to write a note on projectile motion, right? Thank you so much. Take care. Allah Hafiz.